Hello dear students. In this video, we will see how to display a stack. As an example, I have shown that stack has three values stored in it. You can pause the video and answer this question. What is the order? What is the sequence of the values stored in the stack? And your answer would be correct if you say the sequence of the values are 30, 20, 10. Although 10 was added first, then 20, then 30, but the 30 which was added last or pushed last in the stack has become the topmost. So the sequence of values are 30, 20, 10, and we want to display such a stack. Now, we always pass the address of S, as you know from the earlier examples of push and pop functions. So display is going to get the address of the stack which is stored by a pointer called P, and P points to this S. Let's go through the display function. In this, I have again declared a temporary pointer called newrec. I could have used a small name like pointer A or pointer B. Anyway, newrec is the pointer. So there is a pointer called newrec, and listen, newrec can point to a node. It's declared as a node pointer. But right now it isn't pointing to any node because we have not asked it to. The second line is newrec must point wherever p arrow top points. So you can see that P arrow top, check the pointer here. P arrow top is actually pointing to 30. So newrec will point to 30. So our plan was that we will display 30 first. So we have brought the pointer newrec at the node 30, and then we will move this newrec pointer to 20, and then we will move the newrec pointer to 10. Hence, newrec has begun from the topmost node. And now we hang on in this while loop. Check that the while will continue only if newrec is not equal to null. And as you see, check this arrow. Newrec is really not null because newrec is pointing to 30. As this condition is true, we will run the while loop, in which we are displaying or printing in %d format newrec arrow data. So the first value to be displayed will be 30. But then this line is most important, isn't it? Newrec is equal to newrec arrow next. What that means is newrec should change. This pointer should change, and it should point to the same node where newrec arrow next points. You can observe that newrec arrow next, this next, which I am underlining, is actually pointing to 20. So we are saying newrec should now point, this pointer newrec should point to 20. And that's how we have changed the node at which the newrec is pointing. So here is the change I am suggesting. Now newrec no more points to 30, but it points to 20. Well, this process goes on. Here is the while loop repeating. When the while repeats, it again checks. When this while repeats, it checks whether newrec is not equal to null. And newrec is not null because newrec is pointing to 20. So we again enter the while. This while repeats, which prints newrec arrow data. And this time newrec arrow data here I am ticking is 20. And then newrec becomes newrec arrow next. Now newrec, if becoming newrec arrow next, just check. Newrec is no more pointing to 20, but newrec will point to 10. And now go back to while and check, is newrec not null? It is still not null because newrec is pointing to 10. So if you enter the while loop, it's going to print 10. And newrec will become newrec arrow next. This is interesting. Just check. If newrec becomes newrec arrow next, what is newrec arrow next? Observe the next of this node is null. So this right hand side is literally null now. Check again. Nurek arrow, this next pointer, which I'm underlining, is null. So Nurek becomes null. Nurek has now become null, then the while will break because while will continue only if Nurek is not equal to null. But Nurek has become null. So while stops, and what have you now achieved is you have now traveled this entire stack node by node, isn't it? Node by node using Nurek pointer. And then when Nurek cannot follow the next pointer because next pointer was null, Nurek itself became null and the loop stopped. And that's the end of display function. Dear students, we have seen actually three main operations of stack till now: push, pop, and display. Although empty was one more function I discussed in the earlier video, but empty is not an operation, it's just an inquiry whether the stack is empty or not. By the way, in this program, I have written one more function called destroy, which will destroy or delete all the nodes of the stack at once. But that's not interesting. Out of interest, I have written here. You can go through it and try to understand what it does. By the way, all these functions, push, pop, have been called from main, and have been declared above. Obviously, because all these functions, push, empty, pop, display, and destroy, have been defined below main, so they have to be declared above main. Here we come to a conclusion or end of stack data structure using linked list. But we will return to this topic of stack when we try to implement stack using array. Thank you very much.